Hello, PreCalc. It is the After Friday class, video class. So that is going to be viewed on the 4th, 5th, or 6th, sometime between Monday's class. So tonight we're going to continue solving trig equations. And we're going to put in one complication tonight, and that's all we're going to deal with. So let me give you the equation they're going to solve, and you tell me what the complication is. Alright, 2 sine squared x plus 3 cosine x minus 3 equals 0. So the command is solve. So once again, at the end of our story, somewhere down here at the end, we'll have x equals some value. And we're looking for an angle so that when we put it in this equation for x, it creates a true statement. So 2 sine squared of that angle plus 3 cosine of that angle minus 3 will give us 0. So I notice the complication, do you? I can hear you through the camera, and that is, yes, you're right, the sine squared here and cosine here, we want to work in the same function. We want to work all in sine or all in cosine or all in any trig function, but not two at once. So how could I easily change this to sine or this to cosine? Alright, the quick way is to look at this one and remember the relationship that sine squared has with cosine squared. Sine squared x plus cosine squared x equals 1. So that's one of our basic Pythagorean IDs. So if I get sine squared, one of the forms of that is to get sine squared by itself, moving cosine squared to the other side. So this tells me anytime I have a sine squared, I can replace it with 1 minus cosine squared. So that's what I want to do here. So instead of having sine squared, when I get to it, I put in parentheses 1 minus cosine squared x plus 3 cosine x minus 3 remain unchanged from the problem. So all I did was substitute sine squared with 1 minus cosine squared. So now the function has all cosine to work in. So multiply by 2, distributing the 2 will create that. Let's combine like terms and put it in a nice order. It's always easier to work on these when the lead coefficient is positive. So I like when the negative is in the front like that, I like to multiply the whole thing by a minus 1. And I can do that if I do it on both sides and there is an equal sign in the problem. So all the signs, the SIGNs, will change. Alright, so now I'm in familiar territory. So we learned how to do these the other day, and this is a trinomial that we need to factor, thinking about FOIL in reverse. So what first times first has to give you this value, so it must be 2 cosine x and cosine x. Last times last has to give me plus 1. So it's either going to be plus 1 or minus 1 minus 1. Because we have to get a negative middle term, let's go with the minus. And checking the inner terms and the outer terms and adding their products, we get a minus 1 cosine x and a minus 2 cosine x. So that gives us minus 3 cosine x. So once we have factored it, and the whole reason we factor it is if one something times something equals 0, then either the first thing equals 0 or the second thing equals 0, second factor, or both. So we're just going to take each one and set them equal to 0 and go ahead and solve both branches. So this one, the 1 comes over, this is equal to 0. The 1 comes over and divide by 2, so we get cosine of x equals 1/2. Now notice I didn't give any, in the very beginning of the problem, I didn't give any restrictions for the answer, so we're going to look for all the infinite number of answers. So where on the unit circle is there an angle that has the cosine, which is the first coordinate, of 1/2? And it turns out that happens at pi over 3. So if I was drawing the unit circle, it will happen not there, but there, pi over 3. And also it will happen at 5 pi over 3, so right there. So I look for a relationship between those two. Like, are they exactly pi units apart, pi radians apart? They are not. So I'm just going to add 2 pi to each of them many times, or as many times with 2 pi n and 5 pi over 3 with 2 pi n. And that will give us an infinite number of answers. All right, so those were the those are the 2 answers from the first branch, and sometimes I forget about the second branch, so I don't want to do that tonight. So go ahead and solve that branch. Cosine x minus 1 equals 0. Cosine x equals 1. So the first coordinate has to be a 1, and that happens at 0 radians, or and then we can, that would be right here, and we can go around and around and add 2 pi n. But 0 plus 2 pi n looks a little awkward, so I'm just going to call it 2 pi n. And those are the complete answers for this trig equation. Alright, so believe it or not, that's all we're going to discuss this weekend lesson. And we're beginning the beginning the second quarter on Monday. And we just finished the first quarter and handed in a test, so we'll just take a little breather and just do one complication of solving trig equations. So come on Monday knowing how to deal with this fact, with this problem, when the equation has 2 functions, different trig functions, and we want to work it in one. Alright, so hopefully that makes sense, and you can bring those ideas with you in your bag of tricks on Monday. So till then, have a good weekend. Over and out.